Yeah.
It doesn't work with Firefox?
No, you were trying with the Firefox.
Yes.
Okay, so that I even shared a Google Chrome extension, so it doesn't
Oh,
work with.
okay. Okay,
Okay,
okay. I was with this thing, Firefox.
okay.
Okay, let's start review here only, I think.
Oh yeah, and it's live now. I think
Sorry?
we have started recording. Okay, so starting.
What happened?
No, no, there's a confusion. Who is going to start? You choose.
Hello?
Hello, Yogi. Can you hear? Listen. Vishnu, can you hear me?
Hello.
Hello?
Yeah, I can hear you. Can you hear me?
Yes.
Okay, so Yogi seems to have some problem.
Yeah, even I can hear you now.
Okay, so there is just a confusion. Who will start? You,
Manish will start.
Anish.
Let's start with Kochi.
No. Okay. Okay, we will share the screen.
Okay, great.
Yogi, just a minute. I'll share the screen. I haven't completed the assignment. I'll copy the file and then share the screen. Just
Okay,
2 minutes.
no problem. Next student. Next one.
Everyone is having the same problem. Like in the morning, I told them that the repo is having some problem. In the morning, there was some problem with the repo.
Yes.
So it was not showing the updated pages. So I just told them. So then everyone decided that okay, let's not push. Let's have it locally.
Okay, what about Vigyan Ashram? Mahavir? Anyone? Dipali is there, I think.
Yes.
Yes. Are you ready?
Yeah.
Okay. So who's going to come first? Mahavir?
Arundhati.
Arundhati. Okay.
Arundhati, yes.
Can you share your screen?
Okay.
Mhm.
Wait a minute.
Okay.
Uploaded my website.
I can see that. Yes. So you want me to share the screen?
Just a second. Okay. Actually, okay. Now I'm telling. I'm not sharing my screen. Okay.
Okay. I'll share from.
Uh,
Okay. Yes. Go ahead. Start. I can see the screen.
okay. In this week, I do electronic design.
Uh,
Actually, I'm from basically electronics background, so I know the some softwares about the designing, like OrCAD and Proteus. But Proteus not I used well, but OrCAD I used previously. But this time I go through the tutorial and I saw the Eagle tutorial. So I studied first that and then I go through it, and actually it is very good software.
okay.
So my whole assignment in Eagle. I draw that diagram, and I insert one LED plus resistor and one switch in diagram. I put one smiley there, and when
Yes.
we start the button, then that smiley, the LED blink in is a smile.
Okay. Where's the complete circuit?
In last, actually, programming is remaining.
Okay.
Tomorrow we will upload that. Means we do simulation, but we cannot uploaded it. Tomorrow I will upload it.
Okay. Okay. So you have made a smiley using milling, and you have one LED there, right?
Yes, yes.
Okay. 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 Fine.
And the
So.
procedure of PCB milling, I do in our fourth assignment. So I give the link of that. I will give the link of that
Okay.
procedure.
Where do you get the libraries from? Fab libraries.
Yes, I use the Fab libraries.
Okay. So have you written how to install them or any link? No, right?
Library?
Yes.
Yes.
Okay. Okay. I can see. Hmm.
Yes.
Okay.
Actually, the diagrams are
And
so self-explained.
right. And how you are routing the all those components? How you are connecting those components
Okay,
together?
first I draw in schematic my whole structure, and then I will switch to board, and then I one by one all the components putting in that uh, box, and then I will go through the wire and connecting all the components, and after that I go in the layer and give the top layer, then dimensions, then values.
Okay. So why you are not cutting the PCB from with Modela? Are you
I'm
facing
cutting
any
with
problem?
Modula. Yes, yes, I have some problem with that. After completion of whole circuit means my program is run, then I will cut it again. Firstly, I check if it is run or not, and then I will go for next.
Okay.
At the cut time, I have some problems with the modular machine, and for that bit,
Bit got broken or how it is?
not broken, but it is not working well. Means it is just at the surface level. It cannot cut it. Means I give offset pi, but it cannot be work well.
Okay. So what about increasing the depth? Have you tried
Depth, yes, I increase
cut
it
depth?
minus 1.8.
Acha. So still it is not cutting.
No, yes. So after programming, I will do it again.
Okay, no problem. So you have designed your own PCB, right? Completely
Yes,
new one. Okay, no
yes.
problem. Okay, fine. Any issues, any queries, any
Uh,
comments about Eagle or any of the things that
uh,
you did this week?
no, 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 anything.
So how is Eagle compared to RCAD or any other CAD software that you
Uh,
have used
it
previously?
is very good. Actually, I have one doubt that when I use Proteus, then I import the image which is I made in Eagle. Okay.
Okay.
But when I uploaded the program to that 18E44, cannot be uploaded. Uh, it is happen means it is right or not that we are directly uploaded that program, because firstly I uploaded on Arduino, then I
Okay.
changed the I directly import our image that we have made in schematic in Eagle.
Okay. So you guys are directly importing that image, like what's the format? .png to
uh,
Proteus.
bit bitmap, it's bitmap.
Okay. Do you have screenshots?
No.
And how you guys are programming it? Are you uploading hex file?
um,
Are you linking hex
yes,
file to Proteus?
Yes, I merged two programs, a button and LED, uh, in Arduino.
Okay.
There is some programs with Arduino, means simple examples like LED blinking and switch button. So I merged that both programs in Arduino and changed the name of our IC, means programmer.
Oh, okay. So that should work, right? So what you can do is like you can try with your FabIce module. Wait, let me disconnect from. Yes. Can you hear me now?
Yes.
Okay. Now I think I can share the screen. Yes.
Hello, Yogi.
Yes.
So Pradnya here. Just make sure the students which are going to present tomorrow, they have completed their assignment, current week assignment, and they actually need to talk about their final project. So I think one is from Bombay Fab Lab, two is from Vidyana Ashram,
Yeah, I have the
and
list. Jatin, Raj, and Abhiman.
yeah. So please make it sure, and tomorrow they should present, okay, in the lab, and they should complete with the final project and the current week assignment.
Yes. Okay.
Okay, so might be my boarding started, so I'm leaving. Okay, bye.
Okay. Happy journey.
Thank you. Chalo, all the best. Bye bye.
Yeah. Yeah. Bye. Okay. Yeah. Now everyone can see my screen, right?
Yes.
Arundhati?
Yes.
Okay. So what was the problem? So you're not able to upload the code into IC.
Yes. When I was open, it means I import the file in Proteus. I upload that program in Proteus, so it cannot be happen.
So in Proteus it is working fine. So like simulation is happening or not?
Not happening.
Okay. Have you checked all the wirings and everything? Is the clock speed okay? Have
Yes.
you? Okay. What error it is giving?
Means when we click on that IC for uploading the program, at that time the Arduino name is always there. Means there is one box where the Arduino's program name is there. That file name is there. So there is no any name of our IC.
Okay. So that is fine. So you have to go to the program and select the hex file. Did you do that?
Okay.
Yogi, just a minute. I think she's talking about like she's trying using Arduino to program the board, right?
Yes.
But why you then you're using Proteus in between?
She was trying to simulate, I think.
Yes, I want to simulate.
Okay, so let's get
So you
things
want
clear. Okay, there is a simulation part. Okay, leave that now. Now for the programming
Okay.
part. So you made the program in Arduino software, and you are using that software to upload the program, and you are not able to find ATtiny44 in the list, right?
Yeah. Yes.
Okay,
No.
for that, okay,
Hello.
speak. Yeah, speak.
I find out the name of 1844.
You have it.
Yes, I have it.
Okay, so now what's the error?
Yogi, hi, this is Abhijit from Vigyan
Yeah.
Ashram.
Yes.
Yeah, so Yogi, what happened is we tried to simulate in Proteus,
Okay.
and we used Arduino as our this thing, right? Our IC.
Okay.
Okay, so that time the simulation was okay. The LED was, I mean, blinking when you push the switch and all. That time the program was working. That is fine.
Okay.
But when you import 1844 in that thing instead of Arduino,
Okay.
then that time the simulation was not running. So that is the problem.
Okay. So in the ATtiny44, have you selected the clock and fuse bits properly in Proteus?
Uh, I don't think so. I don't think so. So how do we do that?
So just double click on the ATtiny44 schematic of
Yeah.
Proteus.
Okay.
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 Select the fuse bits. The fuse bit data is so fuse bit numbers that you can get through the datasheet of whatever IC that you're using. Okay. And then select the hex file that you have created using either of the software. And then you have to link that, browse that hex file, and then click OK. Then it should work. So there are two problems. The Proteus is little heavy, and many of time it gives error that simulation is not able to happening because of heavy load. But that is the only one problem that I have seen. Otherwise, even if you don't connect the VCC and ground, it will work. The simulation should work in Proteus.
Yeah, okay, fine, we'll try that.
Yeah. Okay. Okay. So we can move on to next, I think.
Okay, thank you.
Okay. So
Hi,
who's
Yogesh.
coming next?
This is Abhijit.
Abhijit. Yes. Okay.
Yeah.
Yes.
Yes. Yogesh?
Yeah. Oh, go ahead.
Yogesh, can you hear me?
Yeah. I can hear you.
Yeah, fine. Go ahead.
So even you are using Eagle?
So I've used Eagle. Yeah, so I'm not from electronics background, so I went with the majority of what people are doing.
Okay. No problem. Explain. Yeah.
Yeah, so yeah, go ahead. So I used Eagle,
Okay.
and then
Downloaded the library.
I've downloaded the Fab library from the Fab Academy site, and then I added it to the this thing in Eagle. And then here, this was a big thing. Right? This was a big confusion in what amongst we people.
Right.
So we were confused of whether intersection in schematics or crossover in schematics is allowed or not.
Okay.
So there was a huge. So for people like me, I've just highlighted this point that okay, in schematics it's just you just specify the connections. You don't basically make a route over there. So this is for the people.
Right. Correct.
People like you. Yeah. So yeah, go ahead. This is the and the below diagram is what I got from the tutorials. This is where they have shown the basic connection of including your switch and LED.
Okay. Okay.
Yeah, and then the basic steps of how you switch to boards. And yeah, so first I've done this routing, and then I've just tried to reduce the size of the PCB as much as I can. So that is what I've depicted in these three pictures. So it started with a bigger PCB, and then it got smaller and smaller.
Okay.
Yeah, I'm not able to see your screen. Yeah, okay. So then these are the DRC checks. So I got few errors of DRC.
Okay.
Excuse me, for the clearance. So I have highlighted them over here.
Correct.
And then I've corrected them. So I've just depicted that you can edit the limit of clearance of how much Eagle allows you to have clearance or whatever.
Okay, so you got rid of error by tweaking the parameters.
I got rid of error by editing or rather moving the traces, not by editing this thing, the clearance. I kept the clearance to the default of what they were in Eagle.
Okay. So you have rerouted that wire.
Yeah, I rerouted that wire. Yes.
Okay, cool. Okay.
And then the basic steps. Then how you create a border, right? The interior part of it. That was a big. This is what we did not get by reading few of the blogs of previous people. So I made sure that if someone reads this thing, he gets it clearly over here.
Okay. So which command are you using?
So I basically smaller down the dimension layer of the of my PCB, and then I made it to the whatever cut length I wanted, and then I changed the width of the dimensions by using the command change, and then changing the width to 0.6049. I am using mm as my units, Now, then I've given some traces, original files, and here there was a problem, right? Trace width. So
Yes.
so the traces which were passing in between the ICs, they got shortened, right? They were touching the pads of IC. So
Yes.
this problem was not shown in Eagle, but when I removed the PCB, it came to surface. So then I again went back to Eagle. Of these three traces only, the same.
Which three? These three traces?
But these three, the ones passing in from the IC, crowding over there. That's why, yeah. Can you see them?
These traces inside below the IC.
Yes. Yeah,
Okay.
in between the IC, in between the
In
IC.
between the IC. Okay.
Yeah, 1, 2, 3. Yeah, yes. The problem.
Okay.
So I kind of wasted one PCB over there.
Okay. So haven't you checked before milling the actual PCB using the software, using the fab modules?
Yeah, in software, there was a clear this thing. Even
Which
DRC did
software?
not show me.
On modules?
Even
No. I'm asking about fab modules. Have you tried with that?
no, I have not. Fab models. What do you mean? I did not get.
So whenever you make traces or any PCB, first what you have to do is you have to make it into a PNG image. Okay.
Okay,
Then
fine.
you have white tracks and the other black is rest of the part is black. Now
Right,
take
right.
that PNG image, upload it to fab modules, okay,
Yes.
and check every track. At least you have to see.
Yogesh, your
So
voice
can
is
you?
breaking.
Hello, can you hear me now?
Yeah.
Okay, so
Yeah,
what you have to make sure that when you upload it into fab module and when you calculate the tool path, it will show the
Okay.
tool path in blue color, right?
Yes.
Yes. So what you have to check is the tool is moving through between these two paths or not, between these two
Okay.
traces or not. You have to
Okay.
check that. At least the tool should pass at least for once or twice.
Okay, fine.
So before
No, okay.
actually
I
building
did
the
not do
board,
that.
you have to check that.
Okay. I
Okay.
did not do that. Yeah.
Okay. That's
Yes.
the thing. Okay.
Okay.
We can go
Fine.
ahead now. Yeah. And you have traces. Okay.
I have traces. Yeah, I did traces.
Is it
And
is it your
then,
board?
yeah. Sorry.
Is it your board? No clearance
Hello.
for the pad?
Yogesh.
Hello?
Yeah, Yogesh. Your voice is kind of breaking.
Hello? Can
Hello.
you hear me?
Yeah.
Yes.
Yeah.
Hello?
Can you?
Can you hear me?
Yeah, Yogesh.
Yes.
Okay. So
Hello, Yogesh.
your Eagle schematic or the board interior is quite different than board that you have made. Is it? Is it the case?
No, that is not. I've just included some. I've just rotated the LED.
No. The thing is, I can see a
Okay.
curve here, which is not there in PCB, the Eagle schematic.
Can you? Oh yeah. Okay, the interior. Yes. Oh,
Yes.
yes. So at the end, I did a curve over here.
Okay.
Okay, so I have to include a picture of that, right?
Yes. Okay.
Fine.
Okay. I can see that you
Okay.
have uploaded
Yeah.
pictures. Okay. Fine.
Yeah. So this was a troubleshooting. This is what I was talking about, right?
Yeah.
So yeah.
Okay. Have you tried scraping it off using any knife or any tool? Any sharp tool?
I did, and I broke the traces, right? Can you see? You can see that in the.
Yes, I can see that.
I tried it with the nose plier. I tried it with the nose plier,
Oh, that
and the
is
whole
too.
track just ripped out. Yeah, it's too
Okay.
tough. I mean, I could have done that, but I don't know. I should have used some
You could have used
light
some
tool
kind
or
of
something.
blade.
I don't know. Okay.
Okay, so you're trying to fix it using copper tape, is it? What are you doing with
Yes, I did.
copper tape?
You can see. So what I did was I cut this thing, a square shape,
Okay.
and then I soldered it to the outer this thing, right? Outer track where the track is not it is not an actual conducting track, right?
Right.
Threshold, you can see it.
Okay.
So, and then over there, and we check the continuity,
Mhm.
and that is working. Yeah.
Okay. So do you have video for your board? Is your program board is programmed?
No, it is not.
It is not. Okay. No problem.
No. Okay.
Did you do any smoke test? Have you suspended it to power?
Oh
Hello?
yeah. No, I did not. I did not.
Okay. Okay. Try doing that also.
Okay. Fine.
Okay. So you have everything. Okay. Fine.
Yes.
No problem.
So, Yogesh, I have one doubt about Eagle, right?
Okay. Yes.
So, I downloaded this Autodesk Eagle, and then
Mhm.
every time I start it, it is asking me to sign in. I went to some this things, blogs and forums,
Okay.
and there they are saying that you have to sign in every 14 days.
Yes.
So
It
every
is the
14 days,
case.
but
It
that
is.
is not happening with me. I have to sign in every day when I. So if there is no internet, I basically cannot use Eagle.
Is your
So that's
CMOS battery is okay?
Yes.
So it is taking care of time properly.
Yes, yes, it is.
I don't know. Maybe Sibu can talk. Any comments from Sibu?
yeah. So Eagle is having like they went to the subscription model. So either 14 days in some cases, like when you are you using Linux
No, I'm using it on Windows.
Windows. Yes.
in Windows? Okay. In
Okay.
Windows, I don't know. Like in Linux, there is a problem. Each time, it Eagle may not store the cookies properly. So Eagle is using something like a cookies, like WebDriver is not exactly cookies, something similar. So if it get deleted when the session is not saved properly or something, it get deleted and you will have to sign in again. Maybe with Windows also there is some similar issue.
So how do I solve?
Basically,
How do I go about?
I don't know. Like you, the problem is like in Windows you won't get any logs, any debugging logs or anything like that. So I don't know. Like
Fine, fine.
you will
So
have to
should I try running it?
and find out where to get the log of Eagle, the runtime log. Okay,
Okay.
and then you will
Hmm.
get some message. Why is it happening? Or when the cookies got expired or all these details you will get from the log. With this you can Google
Okay.
and get
So
some.
event manager is a tool which you can find in Windows. So there you can get
Okay.
a log of every software which is running and the errors or whatever it is doing.
Okay.
Something like Intel in Linux.
Okay. Fine, fine.
Or
I'll
maybe
check.
the simple issue is if you're not if your timekeeper is not proper, then that might be an issue. But if,
Okay.
as you're saying, your time is okay, then maybe the cookie
The
problem.
time is okay. The time is okay.
Okay. Anything else to share?
Uh, there's nothing right now.
Okay. Fine.
Okay.
Why is your PCB mill like your PCB is like
Yes.
milled with very high depth? Like I think it's like 0.3 or
Yeah.
0.4.
Varying. No, it is 0.2 depth minus 0.2 depth.
Minus 0.2. Okay,
Yes.
why you're not using 0.1?
Because I tried with 0.1, but then I think there was some issue with my bed level,
Okay,
and
so one
I
side
tried
get
to fix it. Hello, Sibu.
yeah. So have some like, issue with the bed leveling, and one side of the board will get milled and other side will not.
Okay.
Is that issue?
Yes, that is happening. That is happening. So one side just it just copper of it. It doesn't go deep inside.
Okay.
So that is what we did. That is what I did.
Okay. Yeah. So be careful when you do 0.2 mm because the bit will break very easily.
Bit may break. Yes, bit may break. Yeah.
Yes.
Yeah.
Okay. Okay.
You will have to reduce the feed rate.
Okay. Fine.
Okay.
Okay. Who's
Okay.
next?
Next. Yeah. Fine.
Yeah, good evening. This is Nishtha this side.
Sorry?
Nishtha.
Okay. Yes, so how was the electronic design week?
It was interesting and a bit frustrating too because the board was a bit complicated. So I started by making my schematic in Eagle,
Okay.
and I chose Eagle because I used Eagle before in week 2 assignment, in which I basically laser cut a booklet in which I did.
Okay.
So Eagle was a bit comfortable, so I ended up starting with it itself. And after putting my all the components inside, I calculated the resistor, and
Okay.
which I actually took reference from one of the old students' website, and then I started when I switched to board. Then I realized that there are lot of connections which are not actually connected. So I went back and again started the schematic board.
Okay.
And then when I came back, I did ERC and DRC, the
Mm-hmm.
design rules and ERC, and there were less errors. The errors were zero, but there were few warnings which I felt was inevitable. Like they had to be there because they were telling about power pin and the
Yes. Few parts have don't
capacitor.
have value. Yeah, correct.
Yeah. So then this time I basically designed my PCB in the form of open hand,
Okay.
Chandigarh city, which is in
Okay.
North India. So I went on editing it in Photoshop first. Then I
Okay.
imported it in through in form of bitmap on my in my Eagle. Then I assembled my components on it just to check if the size and everything fits well.
Mm-hmm.
Then I did auto routing. So in auto routing, I was confused if I should go for it or not because I referred few websites in which they were saying manual routing is more better, is
Yes.
better.
Okay.
But when I did auto routing, they were giving me different kind of variants. So I kept moving my all the components, and I achieved 4 or 5 variants in which I got 100% auto routing.
Okay.
So I chose one of them, and again I brought it to the Photoshop with my in the form of PNG,
Okay.
and then yes, I basically milled my PCB with 0.010 drill bit, mill bit,
Okay.
and then we had one Fab Academy plus doctorate in sustainability in Fab Labs from Finland. So we had a really good conversation with her regarding Fab Labs.
Okay.
So that was an interesting part of the week.
Cindy. Yeah.
Uh, yeah, right, Cindy.
Mm-hmm.
So next I stuffed my PCB with the components. So I added 3 LEDs and 1 switch.
Okay.
So 3 LEDs are basically the fingers above 3 fingers of the open hand.
Right. Yeah.
And I tested with multimeter. So
Okay.
I'm yet to do the programming because I haven't explored about the programming yet.
Okay. So how are you testing it with multimeter? Only the continuity?
Sorry?
How? What are you testing with multimeter?
Yeah, the continuity.
Only continuity between the tracks and
Yeah.
every adjacent pin. Okay.
And also for resonator, I tried something I think people might have tried it before. Basically, I used hot gun to get resonator on my PCB board because it was very difficult to actually solder it.
Okay. Yes. Because tracks pads are beneath the resonator.
Yeah.
Okay, that sounds great. Okay, one more question. So when you were
Yes.
explaining about the schematic and then switching to the board, there you said
Yeah.
there are the problems where few of the components are not connected to each other, right?
Yeah.
How do you make sure that they are connected? Do you know any tool in Eagle with which you can
So
check.
when I went back to schematic and I did ERC, right? So first of all, the mistake I did, I ignored them in my first trial. So because I got to know that warnings can be ignored, so I ignored warnings. But when I saw in my board that there were few connections which were not there, so I went back to schematic and I again did ERC, and I went through each one of the warnings and followed it. So I
Okay,
was
so
able to
there's
actually get my
okay, so there is one more tool that you can use, which is known as
yeah,
show.
please.
Show command. Can you see a little eye here? Can
Yes,
you see my
show command,
screen?
right?
Yeah, show.
Yes, I can.
So you know this command, how to use it?
No, I haven't used this in Eagle yet.
Okay, it's simple. So you switch back to your schematic, click on the command, and then double click on the wire. Okay. So consider that you're clicking on this wire, which is going
Okay.
from R1 10K to the PB3 of this IC, Tiny 44, right? Double click on this wire with the show command, and it will highlight this pin and the resistors this pin. Okay.
Okay, so it will show that it's connected.
It is connected, so you have to see that this wire is highlighted and the other part of the resistor or other part of the IC is getting highlighted or not. So this is the thing that you can use to check if the connection is there or not. Also, it will indicate every instance of the wire available on this schematic. So consider that you have a multiple grounds, okay?
Okay.
And if you click on the ground, so it will highlight every other ground present on this same schematic. So this is the trick that you can use. So keep trying that command.
Yogi,
Yeah, thank you so much. That's very
Yes, Sibu.
okay. So while you are in Eagles, can you also show to make the schematic using labels? Like all these people, they are using, they are connecting all the pins using net. So
Yes.
for a big
Yeah.
circuit, it's quite uncomfortable to just see
Yeah,
the
very
schematic.
yes, yes, it's very nice comment by Sibu. So what you can do is okay. So what you can do is rather than connecting all these wire to this point, what you can do is you can name this node. Okay,
Mm-hmm.
consider that node 1. Okay, and
Okay.
whatever you want to connect, you can use directly right click on the wire and name it node 1. Connected to the node 1. So consider that this is very useful when there is a very complicated circuit. So consider that you have
Yeah, I was looking
circuit.
for that feature actually. So thank you, Sidhu.
Yeah, yeah. So that's the same feature as present in Proteus as well. So you can use
Okay.
labels to connect. Okay.
Yeah, I have one question. Actually, I'm yet to try simulation and programming. So,
Okay.
can you just give me an idea what would be the best software to use for programming? Only with the if like Eagle by importing Eagle file.
Programming, importing Eagle file. So,
Simulation for by importing Eagle file.
so I have no idea about how do you import Eagle file into any other simulation software, but there's one Proteus software. I don't know. I don't know. You can able to import the Eagle files in that. So Proteus is the best.
Someone mentioned that probably we cannot.
Yes, I think we cannot because they both use different. Cebu, any idea?
No, I haven't tried any simulation as of yet, but I think most of the softwares support exporting to SPICE format.
Yes, I think you can try with exporting Eagle file into Spice one. Okay, so if you want to, if you are just beginner with a electronic circuit, then you can use 123D circuits, which is the very easy online utility web app kind of a thing, where you can try simulating different components. They have Arduino and all different kind of sensors that you can directly use, and you don't have to install anything. So that's the good point of start for
So
simulation.
simulation can be done in the Eagle itself also.
No, no, Eagle doesn't support any simulation. But Proteus supports PCB designing. So if you are master of Proteus, you can simulate it, program it, you can make hex file out of it, and then even make the PCB. So Eagle is complete IDE for circuit designing, I'll say.
Okay.
But how are you guys using Proteus? Proteus is it free? Like,
No, it's
is
not
it a
free.
trial version available?
It's not free. That's the case.
Then this is going to be a big problem after some time.
Yeah, yeah. So that is the thing.
Like if someone comes and like if someone from Proteus find that all these people in the Fab Labs are using Proteus, they will just come and ask, where is your license? That's it. Done.
Yes. So that is the problem with Proteus. It's not free, but it's like a complete ID, complete set of tools that you want for PCB designing. Okay.
Yeah.
So any more queries, questions, comments?
No questions. Also, while I don't know if other people are also done this customized electronic design. I would like to go through all the websites once.
Oh yes.
But what the problem I faced while doing it, but I achieved it successfully. So the thickness and thickness of the circuit lines.
Tracks. Yeah.
So
Okay.
while I was editing it while I was editing in Photoshop, I
Mhm.
had to basically increase the thickness of all my lines, and that made me also move my few of the components to left and right to expand my circuit.
Okay.
So that was there too.
Okay, so in Eagle there's change command which you can do it for all the group. So maybe what you can do is in Eagle when you are routing the wires, what you can do is you can route at any with any length of the wire, sorry, width of the wire, and then you can select all the wires by making it group. So there's group tool here.
Yeah, I tried that.
Yes, here is a group tool and then change tool. So right click and change group that you can do. Okay, so very nice customization of the PCB. You can
Thank
make
you so much.
a variety of any variety of shape. Okay, let's move ahead.
Yeah, thank you.
Okay, where are your files?
Sorry.
Where are your files? Okay, zip
Oh,
file.
if you go to the last, you can see my files.
Yes, board and schematic. Okay, fine, no problem.
I think she should embed the file design files in the website itself, archive itself directly, not in the Dropbox,
Yes, not in the Dropbox.
because it's a very small
Saw
file.
that. I saw that in one of the Yogesh website. He embedded. Hello.
Okay. Yeah.
Yes.
So the thing is like
So
unless the
I
file is very big, like 10 MB or 20 MB, you embed them directly in the archive.
You're right. Okay.
Okay, let's move ahead. Who's coming next?
Dipali.
Dipali.
Hello.
Hello. How are you?
Yes. I'm fine.
So how was your week?
How are you?
Oh, great. I'm fine. Very good.
So
Seems like you're using
this week
Cocopelli.
is sorry,
Seems like you are using Cocopelli.
I can't hear.
Hello.
Hello.
Can you hear me?
Hello.
Hello. Can you hear me?
Yes.
So are you using Cocopelli?
No. I'm going through the Eagle Autodesk Eagle. This is my first time using that stuff. Basically, I'm a mechanical engineering background, and it is very tough for me to learn electronics things, calculating the values of the registers and how to simulate them and lots of things I learned very first time. So
Okay.
I was going. I went to the Eagle, and it's quite good software to learn. And
Mm-hmm.
this is my schematic. I use add command, mate, and after that, while switching the board route change, all that once. And yes, I found some errors like overlap in wires, and then I fixed it.
Overlapping
And
pads.
overlap wires, like connections
Where? In schematic or board?
on board.
Have you documented it?
No, I'm not done.
Okay.
But
You should document all the errors or the problems that you are facing.
yes, yes,
Okay. Okay.
yes.
Yes. Yes. Go ahead.
And after that, I designed this thing, and I solder it, test continuity with using a multimeter. And I just take time with that Eagle simulation part, but it's not working. I try another one. I'll tomorrow.
Okay. So the depth issue is there. So one side of the board is, I think, it is quite largely milled, and other side is not.
Yeah, yeah,
Yes.
yeah. Some bed issues.
Bed
Uh,
alignment was issue was there.
yes,
Okay.
yes, yes, yes.
So is the LED power LED or so is it indicating that a board has got power or what?
Uh,
What is the purpose
that
of LED?
that one is a fab. Yes, something which is from fab library
Oh no.
components.
Okay. No. Okay. I got the point. So
Yeah.
have you programmed it?
No, not yet, but I'll try on tomorrow.
Okay. Okay, great. Any comments? Questions?
Uh, yes, this is very tough for me to understand the electronics, and yes, it's quite good to learn
Hello.
by the
Yes, go
hello.
ahead. Yes, go ahead. Okay.
I'll try to understand the electronics.
Okay. So one more suggestion that you have to add more description. So I can see
Yeah, yeah.
lot of screenshots around here.
Mm-hmm.
So before the lecture, you should
Mm-hmm.
add few lines of what are you doing exactly, or what is the screenshot is all about.
Mm-hmm.
Okay. Write some description below every
Yeah.
screenshot.
Okay.
Okay.
Yes.
Okay. Nice.
Thank you.
Original files. One more thing. So you have
Yeah.
uploaded your original files in form of
Uh,
images to
yes.
pcb2.png and pcb1border.png. So these are not actual PCB files. These are not non-editable files. So what you can do is you can download these files and directly mill, but you can't edit. So what you have to upload is .sch file, which is coming out of Eagle. SCH and BRD file. Do you understand? Hello? Hello? Deepali? Hello? 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 Vigyanashram? Hello, Sibu?
Yes.
I think Vigyanashram is out. I don't know, some connection. Hello? Who's muting me?
There's a lot of background noise from you. I think Vishnu was just testing where the source is. He was trying to figure out.
Okay, polling. Okay, so let's start with Kochi. Anish, ready?
Okay, we'll start with the Kochi.
So will you share the screen?
Yeah, we will share this.
Okay.
Copy. I didn't copy.
Okay.
Okay, so what's all those background noises about?
Background noise.
Yeah, a lot of people are talking.
There's
Like
no
yelling.
one.
No one. So where is the sound
Yes.
coming from?
I don't know.
Is it loud enough? I don't know. Like, just a minute. Let me. Anyway, let me share. Okay, can you see my screen?
Yes, I can see.
Okay. Okay.
Okay. Hello.
Yes, sir. Yes, I can hear you.
Okay. So actually, if I are here this week, almost all of them have done except me. The works completed. I was being an old man, busy with some family responsibilities. I was off the lab
Okay.
for a few days. Okay. So I have done some work, and whatever I have done, to some extent, I have pushed. What I have done is I have tried to learn KiCad. The tutorial is there.
Okay.
As per the tutorial, I designed the board and I have then generated the layout.
Okay.
Then I have I'm trying to generate the layout of the design that is available within the Fab Academy. That is what I'm doing now. Very
Okay.
short. Okay. So don't be impressed that because of me, my colleagues have done excellently well. So I hope they will be explained to their projects well. There I am.
Okay. So you have installed library and everything?
Yes, I have installed library and they are working. I have learned how to design, how to annotate, how to generate the footprints extra on my own extra. I have learned now how to assemble these things to, and also now I am working on the layout of the PCB schematic available with the Fab Academy. Then the design of the circuitry, I think that won't be a problem for me. That was remaining because of I couldn't spend much time.
Okay. Okay. So what is your plan? So what are you designing in this week?
Yes, I will. I will within 2 days. I hope I will be able to.
What is your plan? So what are you planning to design?
Presently, I am designing the schematic as available in the. Sorry, create the schema layout of the first the schematic available with the Fab Academy for the Hello World PCB.
Okay.
Then I will do some additional buttons and some other circuitry on that, which I have to decide what exactly I will do.
Okay. No problem.
Okay.
Okay.
Thank you.
Yeah. Okay.
Okay, let me leave or anything else?
Yeah, so just remember that include all the original design files that you will be creating in KiCad
Okay, definitely.
and
That I will
host
do.
it manually in the repository only.
Okay, definitely.
Okay. Yeah.
Thank you.
Yeah. Yes, who's next?
Anish.
Anish. Okay.
Okay, can you see?
Yeah, I can.
Hi, Yogi.
Yeah,
Hi.
so I just started documentation. So this is what I've done so far. So I thought of using Eagle at first. Then I found that KiCad was already installed in the PC, so I started using KiCad. So
Okay.
started with the schematic sketch, and
Okay.
then actually documentation is not fully over. So this is what I did at first, and then I actually made the PCB layout and then printed it. I forgot to add ground at first. Then
Oh,
Simon
okay.
actually told me that I forgot that. Then I actually added the ground and then started working on that. So the first board I didn't complete. So I designed another one. On this one, instead of wires, I started using this option so that I can, instead of connecting all the wires here and there, this is kind of very easy layouts and all. The screenshot, is that clear?
Yes,
See,
yes.
instead of using the wires, I just use the labels.
Okay, right.
And then I actually made another design. So in KiCad, I didn't actually, this one I actually auto routed the whole thing. It was very easy, but this one was not that easy. I had to do it manually, the whole thing from the scratch. So except two, I actually managed to route everything properly. So this is the one, and this is the next one I couldn't complete. So I used two 0-ohm resistors here.
Okay.
Then with the help of Cebu, I actually managed to correct it later. I'll actually do the board again tomorrow. I'll document
Okay.
that as well. So instead of using those two 0-ohm resistors, I'll be uploading another screenshot of the board as well.
Okay.
So I designed that and then I actually printed that using Modella.
Okay.
And soldered it. And when you actually called me the first time, it was not working. My board was not working. So I was like very nervous and very frustrated. So I
Okay.
actually checked for the connectivity using multimeter. Yeah, I forgot the name.
Okay.
So using multimeter, I actually checked for the connectivity. It was some parts were not soldered properly. So I'm having some eyesight problem as well. So Cebu actually told me at the first sight itself that it was not soldered properly. So I soldered it again.
Okay.
Just checked the board. I was able to read the board. I haven't programmed it yet. I'll do that after the review.
Okay.
So this is the work I have done so far.
Okay. Great.
So I'll be doing the soldering part again tomorrow. That's for sure. I need to stop using the 0-ohm resistors. I've used two 0-ohm resistors here. One here and the other one here.
Okay.
So I'll be redoing the whole thing tomorrow.
Right. Okay. So by looking at your PCB, I can see there's ISP header, which is 6-pin header. Are you facing any
That's actually on the other
connectivity
side.
issues?
No, that is actually on the other side. I'll add that image as well. So I actually drilled the drilled it using the 1/32 bit, and then actually I put it inside and soldered it. This is the place where it
Okay.
comes. The other side of the board the pins are actually visible. I'll add that image as well.
Okay. Yes. Okay. Okay. So how was Eagle and all?
No, tried only KiCad.
KiCad,
Was
right.
planning to use Eagle. I was so happy that my whole thing was over by Friday. Like I was like super happy. I was like laughing and rolling around. So this was the first one,
Okay.
and then I had to redesign the whole thing. That actually ruined my week. Not ruined, just frustrated that I have to do it again.
Okay. Where are your design files?
I'll add that as well. I added the PNG file. Uh,
Yes.
the mill and cut file. Here it is.
Yes. Correct.
Design file I'll add later. So, as I told, I didn't complete the recommendation yet. So.
Okay. So one more thing. So the below your file there is a trace file, right? So in that, if you look at the corner, the traces at the corner. So why they are like that? So they are going to some other direction and coming back.
This one.
No. Left top corner, which is more. Yes.
Oh, this I just routed that I didn't. I should have
Some
dragged it down, but I didn't do it. That is actually the VCC line.
Model is struggling hard to make your PCB.
This is actually 6 by 5, I guess. 6 centimeter by 5 centimeter.
No. I'm asking about that glitch. So
Oh, that. Oh, okay. I even printed my name. So Model is really struggling.
no. Wait. Let me share my screen.
Okay.
Can you see me? Can you see my screen?
Just a minute.
Yeah.
Just take that.
Now you can see the mouse. So the track is going like this, and then again
Oh,
coming
that.
back.
Oh, okay. I didn't use auto route, right? So I routed it all manually. So the line didn't come straight. That's it.
Okay. So try avoiding these things.
The thing is that he was very frustrated. Like he used 2 0-ohm resistors, and then I went and said you can. I told him like you can route all the circuit without a single 0-ohm resistor or any jumpers. He said no. I tried all day. Like I tried the entire.
I was actually trying from 7:30 p.m. to 12:30 a.m. in the morning. Okay, so I was manually routing it, and he just came there and looked at the picture and said, "You can remove the 0." No, I was like, "No, I tried every possible things and all," and then he just made just 2 arrangements and it was gone. The 0 resistors were gone. I was like so mad at myself and at him because he solved it very easily.
Okay. So one more thing that you can do is while using these sharp corners, right angled traces, that you can filter them like this, that you have did in this track.
Okay.
Also, Anish, hello.
Hello.
This is not the way to add a 0-ohm resistor or a jumper.
Yes.
You are ending the tracks just like that.
So you have to have pad.
I had to connect it somehow, right, to get the board working.
But this is not the way.
But Sibu helped me solve it, so I'll be soldering it again tomorrow.
Okay. And Neil doesn't like jumbo wires.
Yes.
And Neil doesn't like jumbo wires, actual wires.
Oh, okay.
And what this wire is doing over here, the white one?
Because I forgot to add a ground there.
Okay, ground. Okay. Okay, nice.
Capacitor second end was not grounded, so I used. Actually, Sibu actually told me that.
Okay, fine. So you have to add this files.
The design files, and then I'll be adding the new soldered board tomorrow.
Yes.
The thing is, the way Anish did this week's assignment, that's the way it has supposed to be done. Like you make a board, you find out the problems, you like solder jumper wires or put 0-ohm resistor, cut the traces, do whatever, and then you find out all the faults and make a new design and mill it again.
Yes, that is a perfect flow. Yes.
But he doesn't understand that.
That was because I actually tried the first one and I actually gave auto route and it was perfect. In the first try of auto route, it was perfect. Okay, no 0-ohm resistors, nothing was wrong. And everyone here was actually trying auto route and it was not working. I was like super happy, like it all worked out in the first try itself, and then boom, just like that, The whole thing I had to do it again.
Okay. Okay, so you can write down the program flow or your flow chart of your process. That will impress me.
Okay.
Okay. Okay. Yeah. Thank you,
Okay.
Anish.
Thank
Let's
you.
move on.
Suhail, Nancy, or Tanvir?
Tanveer. Okay.
Who? Tanvir.
Hi, good evening.
Yeah. Good evening. Very good evening.
Not really good over here.
What's happening?
Really frustrating week. A lot of errors and we're learning. Actually, we all did it in KiCad, so all of us were studying from scratch. So a lot of errors and a lot of rework was there. Uh, what Anish was suffering today, I suffered on Friday and Saturday. So, so
Okay.
yeah, I'll just start with the thing. So these are the softwares I use. I tried 1, 2, 3 circuits, KiCad, Gym, and Fab modules. Actually,
Okay.
1, 2, 3 circuits I started because out of frustration from KiCad. Spending almost 1 day on KiCad, I couldn't get it routing properly, so I just jumped to 1, 2, 3 circuits.
Okay.
I just brief about 1, 2, 3 circuits. This is some of the videos that I use for getting to know. And from here, like, what my main aim for this week was like, because not many of them were using KiCad, most of them were using Eagle. I wanted to provide it like a tutorial, like everyone who starts from the beginning should know from which tab to click and what dialog box would come up, and from that level. So
Right.
that is what I started here, like how to get started with 1, 2, 3 circuits and how you need to create an account and how to go into PCB design. So just the brief things like what are the components used and why I have used them, like resonator, pin, and etc. And this is about adding components. And I'm not going to explain like each step because it's right there and one could read. So
Yes.
these are
Yes.
just some
So you,
screenshots.
you,
Like
can, you can make separate tutorial page for this.
yeah, sure.
Yeah.
So this is like I just embedded some those 1, 2, 3 circuits directly here, so that anyone could edit or see view it in PCB mode or anything over here. Then moving to traces, like just given the tutorial, small bit of a tutorial here, and this is main place where I want to focus on was the problems that I faced. Compared to KiCad, I completed the whole routing exercise in within half an hour or 20 minutes in 1, 2, 3 circuits. So it was big relief for me. But then later on, for getting the ISP head, there was no component over there. Like in the library, how much ever I tried, the footprint wasn't matching R. And also finally I found one, but even though I was giving in schematic proper connections, it was not reflecting in the PCB design. So I still
Okay.
don't know why. I still don't know why that is happening. Just that is one issue that I found in PCB in 1, 2, 3 circuits. And also many components are not there in the library as compared to KiCad or the other place. So I actually spent about a couple of hours finding the ISP header, and I wasted a lot of time. Instead, I could have just designed my own component and added here. So that was one of the lessons I learned this week. That's what I
Okay.
written here. Like I could have designed it on my own and just place it instead of searching and wasting time.
Correct.
And final result. So here also, because I was starting out with designing, I still had 1 0 ohm resistor to keep across this because I couldn't find a route to close the earth. So I just kept a 0 ohm resistor over here. That was my 1, 2, 3 design final board routing.
Okay.
And this is the Java files. I've attached the design files over here. I can download.
Okay.
Now moving on to KiCad. KiCad is where we have explored as a team whole this week. Like again, same thing here also. I'm going through how to give the library files, how to add them, and there are small differences because this like adding a pretty file to the footprint and some nuances are there that has to be taken care of, like for first timers. So that also I've given
Right.
here. And moving to drawing the schematic again, I've just recreated all the components that I've used. And then
Right. Okay.
moving to, again, I've given all steps on how to start, how to set up a new file and how to go into schematic, everything. And also another thing is there is a website called LED Calc, which you can calculate the resistance, how much resistor you have to give between the LED. Because I have taken a blue LED, I calculated according to it. You can just give this,
Okay.
or else you can use Ohm's law. That's fine because I wasn't very sure about Ohm's law and how, it's simple, but just to be sure, I went into LED Calc and checked it out. So that's how you get sorted out with the components. And now moving on to schematic. So this is how I started out my schematic. I drew all the lines like everybody did. And after checking it out, it was very hard to know like from which wire one was going out. Because I drew it, I knew, but if I had to show it to someone else, like they would find it would be a hard time for them. Like, is this going from here or is this going down or something like that? So instead, I did a global labeling. So again, for global labeling also, I've given the keyboard shortcuts and where to find that button on the KiCad display window. All those is given in my descriptions. So again, this looks much easier on the eyes and it's easy to understand also. So you can just check the names over here and that's it. And then it's more over a clean design. So that's how I went about it, about schematic design. And now before you go into routing, you can check the electrical routing check that is there already in the KiCad module. So a couple of errors, not errors, basically it's more of warning that I've got. It's more like it's shown there is no drive. And that is because I haven't given like 5 volt or anything. I've just given VCC. So the program recognizes that like, no drive is given. Another thing is it shows unconnected pins. Like all these are unconnected pins. This way because like there are some unconnected pins on the IC and on the header pins. So those, so you can just to resolve that also, I've given this troubleshooting. You can just give no connection flag to the pins, and that would sort it out. Then you move on to annotate all those resistors. You give R1, R2, R3. It's all automatic. So that's another step. Then moving on to creating the net list. I really don't know why this is there, but it's the process. I have to explore what this does. But basically, you click on generate and give generate and save the file. 1 second. What is this? Okay. You give save, and then like basically you have to assign the footprints. So we have the Fab library and Fab inventories. There's a lot of libraries you have to download from them. We have to give the footprint to each component. Like the resistance over here initially will be blank. So all these things I've taken from the library on the side. So I've given tutorial on that. Hello, can you hear me?
Yes.
Yeah. Now moving on to, now that is done. Like after you finish all this process, then you click on run PCB new. That gives you the PCB routing window. From there, like Eagle only, you just move around the components and place it in a place that such that the routing is easier. And this is one error I found in KiCad library because I kept a tactile switch in a place, but as you see over here, like the switch is connected like this. So if I actually press the button, it's going to get shorted. So actually, I think the footprint is wrong over here. So I removed that one and I changed it to another tactile switch which was there in the Fab library, which was giving proper footprint. So I replaced that. That was one error. And now, like there are some things called layers. I think it's there in Eagle also, but to give a KiCad perspective, I've given some of the important layers over here. Like FCU is for the top copper layer, which we are working on. Bottom copper layer, we're not working, but it's like for your wanted multi-layered PCB, you have that. Pads and wires for all those connections and edge cuts. So you actually on and off this. I am not sure about Eagle, but I think it would be same, right? You just off the layers, and so that's just given the perspective of KiCad over here of layers. And again, then moving on to design check. This was my final routing. Luckily, or possibly I got without any jumpers or any zero.
Any jumpers, yes.
Yeah, got it clean. So just gave my like Tanvir Hello World board a text over there. And this was the conditions I kept for design check. Like the track width has to be 0.4, Y has to be 0.4, minimum clearance is 0.4. This was like 1/64 bit, that's why 0.4. And I've actually done all this in 0.5 mm track. So yeah, it was quite
Correct.
safe.
Okay.
So this was the design control check dialog box. We have it in KiCad. Just give start
Mhm.
DRC, and this thing should all these checks should happen automatically, and you should get a finished thing over here. If there is some error, all those errors will be marked over here in this column, and you can just directly click on that. It will be shown on the routing, and you could do that. Another interesting thing is that it's not I have not explored Eagle, but like I've heard it from Subbu that there is a lot of selective auto routing in KiCad, so you don't really get a lot of design errors after you run the DRC check, because while you're doing the design, while you're doing the like routing itself, it will show like this place is getting error, and like the design rules are not met. So you can clear it at that time itself. Instead of finishing
Right.
the whole
Yes.
design and then doing DRC and finding error, you can do it on the spot itself. So that was one advantage in KiCad that I found. Now I exported
Okay.
it to SVG, bought into Gym, changed it to PNG, inverted the colors, and this was the milk trace that I got. Uh, and then
Okay.
like there was we had a lot of old PCB, so I thought we'll reuse it. Why not? Because why to use a new one? There was a lot of space left here. So I used this also to cut out the waste part and just the old thing, just
Okay.
the required one, and I milled it. And this was where I found another error which I had. As you can see on the like, this happened after everything done, and I was like, okay, let's finish up the cutting, and I just gave the z axis, right, for cutting. I kept it a bit too deep, so even though it raised up, it wasn't enough, and it just cut right through my traces.
Oh.
So yeah, so that was one error. Hopefully the bit didn't break. Thanks, thank God for that. And then yeah, I did once more. I did once more. I did uh, the milling. And another problem which we faced was that we didn't have those 90-degree header pins.
Right. Mhm.
So we had those regular jumper pins. So here I am drilling holes into those header pins over here, and like inserting all those pins right into the board from underneath. You see over here.
So you are almost using machine gun to kill a ant.
Yeah, kind of. So
Okay.
this is how we got about that problem. A lot of errors and redos in this technique. So now that that board is done, now I went into testing the board. So like last week itself, like last week, I did those pseudo checks, and the fuses were coming.
Right.
So yeah, the communication was happening. So that was good. And just for an extra my happiness, I just tried to flash a small program such that when the button is clicked, it would play. So this is me clicking the button,
Clicking the
and
button.
yeah, so the light flashes every time I click. So yeah, it's
Okay.
working.
So
It's working perfectly.
yeah,
So
good. Very good. Very good documentation. Very neat documentation, and very lengthy. Okay.
yeah, because
So one.
lot of effort and frustration went into this week. So had to get it all out.
Okay. Yeah, that I can see in Kochi lab.
Yeah.
Okay, so design files that you have hosted on Drive, so hosted locally.
Yeah, only this one I've kept. I'll change it to the local ones. The other ones I've kept it locally itself.
Yes. As soon as you have very small files around a MB or two, post it locally.
Yeah, sure.
Okay, very nice documentation. Yeah.
Okay, sure, Yogi. Bye.
Okay, yeah. So next one.
Hi, Yogi.
Hi.
Okay. So actually, I started with KiCad. I'm an Eagle fan actually, but this time I tried KiCad. But comparing with Eagle, I found that drawing schematic in KiCad is so simple, and the only drawback which I found was the dragging the PCB track was slightly difficult in KiCad. So other than that, everything is so simple in KiCad. So this is how I install the total procedure of installing the KiCad I have given here. This is a KiCad library and footprint that you can download it here. And if you just add it to this link, then that is a step 1 and step 2 I have mentioned there. Then you can go for the drawing schematic in KiCad. Then okay, then I have added the LED and switch in this circuit. Then after that, you can move on to adding the components. So the SMT components it is available in the fab library. You can select generally the 1206 there is a 14 resistors and capacitors. You can add it separately here. And after that, designing the PCB. So here also the steps, footprint library, adding the footprint library I have mentioned here. What are the steps to be done to make it working? So then after that, auto routing, if you want, you can add auto routing. Otherwise, the best option will be manual routing. And almost I have completed, and I have added. Finally, I'm forced to add 2 0 resistance. Then the circuit is completed. Then Suhail had helped me to this information regarding PNG format exporting, because I have heard that in KiCad it is very difficult way to export PNG file. But when I tried exporting PNG, we will get a very high resolution PNG file. Actually, it is simple. The steps are simple. I have mentioned the steps. The only thing is we need to export in the SVG format, and then after that you can convert it into PNG.
Okay.
And then how to convert into PNG, that steps I have mentioned here, and this is a picture.
Hey, Lansing, you don't have to actually convert it into PNG. Fab modules can handle SVG itself.
Yes.
You can directly. You mean you can directly export to PNG?
No.
You can directly use SVG file on
Yeah,
Fab
you
modules.
can use SVG files in Fab modules.
Okay, I understand.
You don't have to convert it into PNG.
Okay. Then for I've done the PCB milling. Here I need to write some more text.
Yes.
I will add it today.
Yes. Add before the lectures. So.
Yes, this is a final board. Actually, it is quite very small. It is 28 millimeters roughly.
Yes.
And I have tested it is communicating. I will add that snapshot and details also.
Okay, so you click good picture of the photo which is there on the right side. It is little blur. The button is in focus, but the board is not.
Okay. Then I will take one more pic.
Right. Okay. So original files you have everything. Okay, good.
Thing I have given here. Download. You can download it here. And
yes,
here it is available. Then here.
And how are you taking DRC errors and all? Design rules. How are you taking them?
Design rules. You can click it here. Then it's somewhere here.
Okay.
Design rules. You can click it here. Design rules.
Okay.
Then if you want, you can change the tracks widths. Everything is there.
Okay, so even mention that. So what is the tolerance that you are adding? So while checking the design rules, what are the parameters that you are putting there?
Okay.
And which is according to bit size that we are doing, right?
Okay, I will add it.
So I add a screenshot of that DRC.
Okay.
Okay, good.
Thank you.
Okay, yeah, thank you. Who's next?
Hello.
Yeah, Suhil.
Yeah.
Okay.
So actually, I had completed a documentation just started because I was having a lot of issues and I just completed now. So I didn't take enough time to do documentation. So, Actually, on the first day, I just went through the some basic concepts in electronics. I started with just read the first few pages of Art of Electronics to just get an idea. Then I followed a Fab Instructor page started by Sivu, Yogi, Yadu, and Vishnu. So then I read about some fundamentals like Ohm's law, importance of pull-up resistors, pull-down resistors.
Okay.
So then I started with the KiCad. For this, I followed that KiCad's official tutorial. And,
Okay, great.
then I have included schematic diagram. I just included just 2 or 3 screenshots. I didn't get time, so I'll be uploading today itself. So,
Okay, so you have programmed the board also, right? I can see that. You have programmed the board also, right?
Yeah, everything is completed. It's working well, but I didn't added this into documentation.
Okay.
There are a lot of issues. First of all, my system, I'm using older version of OS, so my default KiCad is version 0.2. So I had to use another system. I installed the latest version, and there was a lot of library issues. I added all these libraries, but there were a lot of files missing. So I downloaded all these files one by one from their Git repository, and I had to add one by one to this library. I lost a lot of time. So after that, I completed the schematic and complete this footprint, and auto routing worked almost well, but there was 1 or 2 lines not connected. So Sibu asked to do this, like do ground as all empty part as ground like this. So everything was okay. So I just had to connect all ground to these empty spaces. So then I took this trace from using plot, and I draw cutout using GIMP. This is my PCB. This is soldered board. Then there was another issue. Actually, this switch is connected to resistor serially. So actually, it had to be like work as pull-up resistor. So it should not be like this. So I just removed this resistor and just short the wire, and it was working well now. I just used dmessage to detect my ISP, and used this command to check if ISP is reading all fuse bits. So it's all working well.
Okay, okay. So read more about the fuse bit, sorry, not fuse bit, the pull-up resistor.
Yeah. So, sorry?
Read more about the pull-up resistor. So you're connecting this switch in parallel with resistor to the microcontroller. Is it the case on the PCB?
No, I didn't connect the parallel. Actually it should be parallel, but I connected serially from this IC like this.
Okay, yeah, sorry, serially. Switch is in series with the resistor, right?
Yeah, switch is series with the resistor, and
Okay,
this and the next pin is connected to ground. So
okay.
it was actually wrong.
Right, yeah. So you add pull-up resistor. So you read about the pull-up resistors on Google.
No. What he is using internal pull-ups.
Okay, internal pull-ups. Okay.
Yeah,
I thought he tried using external pull-ups.
No. Since this is a mistake, I just removed this. Actually, this was 1K resistor. So I removed this and connected a 0 ohm resistor to short this, and then I used internal pull-up resistors.
Okay, okay, not an issue.
Okay, so
Okay.
then LED was blinking and everything is working. So
Okay,
I
so
am
add video also
okay.
of the blinking register,
Mhm.
and write down more about the procedure that you did in KiCad.
Okay, okay. I'll be adding everything. I have all screenshot and all, but I didn't get time to complete include all those.
Right. Okay, and files, original files also.
Yeah, yeah, sure, sure.
Okay. Okay. And one more thing.
Yeah.
This is for everyone, not for you. So everyone
Okay.
is aware of the tool which is known as ElectroDroid.
ElectroDrive? No,
So this
no,
is
no.
very nice software. So this is like a repository of all the electronic things that you have to do. So port pin, the serial pinouts of the every Ethernet and every damn connectors,
Okay, okay.
every chips, the AWG and wire size converters, even series parallel converter, calculator, filters, everything. So you can use that ElectroDroid. You
Okay,
can
okay.
check it on Google Play.
Is it a mobile application?
Yeah, it's mobile application.
Okay, okay. Sure, I'll try that.
Yeah, yeah. This is for everyone, not for.
Yeah.
Okay.
Okay.
So
Okay,
here
thank
I'm sharing the application link. Okay. Yeah. Thank you. Okay.
So,
So
okay, that's all from coaching.
yeah. Okay. So
One thing is like everyone use KiCad here.
yes, yes. Everyone was using. No, but no one was using Cocopelli. Huh?
No one was using Cocopelli, no one was using Eagle.
Okay. Okay. Yeah. Eagle is too mainstream.
Yeah.
Yeah. Okay. So Vigyan Ashram, is Vigyan Ashram online?
Yeah.
Yeah, hi Yogesh, Mahavir this side.
Yeah, Mahavir. Yes. Okay. So let's start with your website.
Right. So you showing screen?
Should I? Wait, I will do that.
So week 6. I haven't updated that website too much. I just put in the images to show what I achieved. Yeah. So basically, this is a 3-tier PCB fabrication. So, for example, let's say I have a trace file, and I have a cut file, I have a shiny file as well. So the shiny file is basically the PCB cutting at 0.02 mm. So that basically gives the copper a nice shiny finish. So I did 3 or 4 presentations for that to see if I can make some imagery in the circuit itself and get some parts to shine, some parts to, let's say, cut out, and some parts to
Very
stay as
nice.
it. The first part was ideally I wanted to make the circuit shiny so that the conductivity can be a lot better. But then I realized it's also an issue to solder it because it's more difficult to solder on a very shiny surface. I started by taking an image of a person, an architect called Le Corbusier. He designed city of Chandigarh, and I broke it into 3 images. So the part I wanted to be a shiny one, part I wanted to be with a few Photoshop effects. And so the first step was that. Then I new to electronics. So plus I didn't get too much time because of experimenting with the shiny part. And at the end, the mill is also a problem in Vigyan Ashram. There are some bed issues. So sometimes it mills perfectly, sometimes it doesn't.
Okay.
Installing the fab LDR and then put in the components. And I did 3 or 4 tries. I imported this as a BMP, switched off a few layers to get this. with this side by side, I try to arrange it or any components and try to auto route and see if I'm getting something like 100% solution. So a few alternatives I tried. So the first alternative didn't give 100% solution. The second one didn't. The third solution did give 100% solution. So I went ahead with that. I didn't really go for manual routing because as such I would have to manual route it in Photoshop since it's an organic ship. So for now I just went for 100% auto routing, then imported it to Photoshop and opened the PNG in Photoshop. So I didn't change the bed sizes. I mean the electronic bed size I didn't touch. The rest of the parts and everything I touched and manipulated the way I wanted to according to the shape of the.
Okay. Hello. 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 Is Vigyan online? Hello. I think they are out again. So Vipul, FabLab Bombay.
Yeah. Hi.
Okay. Yeah. Hi. How are you?
Good. How are you doing?
Yeah, I'm doing good. First class. Okay.
Yeah. So Chitali will come in first.
Okay.
Open up our website.
Okay.
Yes.
Yeah, I'm Mithali is there, right? No, Chaitali?
Yeah. We'll see.
Can you see website?
Yeah, exactly. We can see.
Okay. So, how was your week electronic designing? Hi, Chaitali.
Yes, it was very nice. And yeah, in this week we learned Eagle. Earlier I have never done PCB designing on Eagle. So yes, first step was we downloaded that Fab library, and then we designed the circuit. Basically, in this case, the entire eco board schematic was ready. The main assignment was adding a LED and button to that. So while adding LED, I made sure that I'll be adding a current limiting resistor in that. And since I'm using red LED, I know that for red LED, the forward voltage is 2 volts. So accordingly that for 5 milliampere current, I calculated the resistance value 40. So I used 500 ohms resistor. And same way for button, I use pull up. You can use pull down also, but I preferred pull up.
Okay.
Then at the first time I did auto routing, but in that, and when I milled that board, I faced one problem is that clearance was too less. And then I come to know that for milling it with 1/64-inch end mill, we should keep the clearance at least greater than 16 mil. So then I changed it in DRC settings, and again I made the board. But in that case also, at that time I forgot to change the track width. And I had to redesign my board. In that case, I changed my track width to 0.4 mm. And then auto routing was not possible. So what I did is then I did manual routing. And finally, I completed my board and soldered. I have not yet checked it. I mean, I have not yet programmed the board. So we'll be doing that.
Okay. So your track width was 17 mil. And what about the clearance is okay. Clearance was 17 mil. Okay. So are you from electronics background?
Yes. Yes.
Okay. So avoid these 90-degree connections.
Yeah. And,
you mentor them.
Yeah.
And yes. And what about the DRC the screenshot? You should add that.
I have added that, right? Like 17 mil clear.
Oh yes. Okay. Yeah. 17 mil. Sizes, everything. Okay. Okay. Good. So So you'll be, what is the program that, like, what are you trying to do with this board?
Will be, I mean, if I switch, if I push the button, the LED should glow or something like that. Maybe the LED will play for 2 seconds, 3 seconds.
Okay. Where are the files?
Which files?
Original files, design files?
No, I have not yet uploaded them.
Okay, okay. Fine. You upload them
Okay.
and adding the library, Eagle, download, install, and run. Okay, nice. Any questions, comments about Eagle?
No, I think it's quite easy to learn. For the first time, I was learning that, and yeah, it's easy.
Okay.
I was trying KiCad also, but since library was not available for KiCad, so that's why I again switched to Eagle. So now I learn how to make that library for those how to add footprints. I have to learn that.
Okay, so bed leveling was the issue?
Yes,
Okay,
let me adjust it.
okay, nice. Okay, fine. So have you tried using Cocobelly?
What?
Cocobelly?
No. What is that?
So it's like a PCB designing software only, which is something similar to Antimony. Antimony is little higher version of Cocobelly. So every node of the Cocobelly is Antimony. Sorry, every node of Antimony is Cocobelly.
Okay.
So you can use that also. So and how are you? Why are you using pull up rather than pull down?
It's a purpose. You can pull down also in this case, but mostly people do prefer pull up.
Why are you giving preference to pull up? Any specific reason?
No, I seriously don't have idea about that.
Okay, no problem.
If you can share,
Sorry,
you can tell the reason. I mean, if you know.
your voice is cracking.
Can you tell the reason why do we prefer pull up?
So it's very easy to detect pull up. So because when you are not using, when you are not running any program or something, so then pin is directly getting pulled up. Okay, so that is very rough resistance that you can use. You can almost use any resistance, which is of greater value, which will not let the major amount of current flow into the pin when it is grounded. So it is very easy to detect the click of the button, and that is because we use this pull up resistors compared to pull down.
Okay.
Okay.
Yeah.
Or okay. So who's next? Nice. So you add some more documentation
Okay.
in terms of. So how are you cutting the circuit?
By milling machine.
Milling machine. So where are the interior part of the PCB? Like file for that, PNG file for that. Okay, outline.
Yeah.
So you are making it using Eagle or any other image software?
Using Eagle only.
Eagle only.
I'm exporting it as image.
Okay, great. Okay, fine.
Thank
Very
you.
nice. Okay.
Hello.
Hello. Yes.
Yadu, good evening. This is Clement here.
Who's there?
Clement.
Okay, Clement. Okay. Your page is not up?
The last one. Yeah.
No, it's not up. I don't know why. It's saying forbidden.
Yadu. Hello.
Can you just type
Can you just type week -6
after his name? Yeah.
Week.
Capital.
Yeah,
capital.
Week.
-6. Yeah. .html. Yeah.
Okay.
This is my page.
Yes. Okay.
So I'm from a mechanical background.
Okay.
So electronics design is something new to me.
Okay.
So we try to learn Eagle software to build
Okay.
a electronic design. So as
Okay.
this board circuit diagram to make the schematic using Eagle.
Okay.
One of my colleague taught us how to operate or how to make a schematic and then layout in Eagle. So I've shared the steps I went about learning to make the schematic and to go into the layout mode.
Okay.
Okay, so there's a step-by-step introduction that I've given.
Right.
Then we downloaded this Fab module, Fab library.
Yes.
Okay. After downloading it, you can see all the
Yes.
elements, all the components we can see there, whatever we need to be using there.
Right.
I see it for display what are the components required for making this circuit.
Correct.
Displayed down here.
Okay.
And then for a small, you can say tutorial.
Okay.
So this is the Fab ISP schematic, which I've done the tutorial, you can say.
Okay.
So how to make the schematic, how to do the resistor schematic, or capacitor schematic, schematic.
Okay. Are you using labels for connection?
Yeah, I'm using labels.
Okay. Perfect.
The first step is to first name it and then label it.
Yes. Perfect. Okay.
So this is a step-by-step, you can say, the method of building up the schematic.
Okay.
Okay. Then coming down.
Okay.
The error checking.
Right.
So there you can see that there are no errors there, but there's a warning. I think we can skip the warnings and go ahead.
Yes.
Okay. Which is what I have done there.
Right.
Then since there was no issue there, then I switched on to the layout mode.
Yeah.
Okay. So I've skipped one image there. Actually, when we skip into the layout mode, all the components are on the left hand side.
Yes. No problem. No problem with that.
I've dragged it and
yes.
Put it to the center.
Right.
What I initially did is, so since we had to make a single layer board, so I selected the top layer, did the auto routing as it is. I mean, just without thinking, how is it going to happen? What is going to happen?
Okay.
Okay.
Yeah.
Then I went on doing a lot of iterations. Okay.
Okay.
Then in this image, you can see that we can change the settings there for the bottom layer.
Right. Okay.
And the effort if I
level.
Low, medium, high. So
Right.
there's a difference in creating the auto routing.
Perfect.
Okay. Now coming down, you can see that this is how you can say I've shared the steps of what I did during the auto routing process.
Right.
The effort level is high. Bottom layer I've not applicable, then I continue. Right. Okay. Then you can see when we click the continue button. Okay. This is the window that pops up.
Right.
And when we start the auto routing, so it gives a number of options for creating the, you can say, traces.
Right. Perfect.
These are the different options that the eagle creates.
Correct.
Okay. So
each option has got little change.
100% we can change it with a manual routing.
Right.
Okay. So this is just the initial process what I have done for the auto route. I placed all the components in the. I tried to shift the components.
Okay.
Then I found that the traces are passing in between the pads of either IC or SMD header.
Right.
Okay, which is very difficult. Okay, it's difficult to solder.
Yes, and even difficult
So
to
this trace,
mail also. Yeah.
I converted into PNG. Then I found out that this gap is very less.
Yes.
Then I had to rearrange everything. I tried doing it. Then
So this is the manual routing, or this is also auto routing?
No, this is the manual routing. I skipped some steps there.
Okay.
So after doing a lot of iterations, I came up with this placement of the components.
Okay.
Did the DRC checking, design rule.
Right.
Initially, the design rule, I was not aware about that as to how it works, the DRC.
Right.
Then I went to the literature. I found out that the DRC, the clearance has to be minimum 16 mil.
Correct.
Okay, then I changed that setting there. When I changed the setting, I again found out that the traces are some of the traces, either two traces are coming very near.
Right.
So I changed that setting also. I mean, I changed the routing, manual routing, and I came up with this circuit layout. Okay.
Okay.
Then the problem I faced here is, you can see if you come to the PNG file, the line width setting is different, is uneven.
Right. Yes.
Also was one of the thing which I came to know, that line width setting is also very important to create auto routing.
Yes.
Or when you are doing the manual routing as well.
Okay.
Okay. So when I did the RML file, so it was showing that there's still a minimum gap is not there.
Right.
Not there.
Right. Only tool is passing for one.
Yeah, it's passing through on the pads. So that is not feasible. Okay. Then I'll just briefly tell you what I did. Then I checked the settings thing, the line width, how to do the line width. See, when we open the Eagle by default has inches as its dimension.
Right.
Okay, so we are not aware about that. I was not aware about that as to why it takes inches.
Yeah,
So
even width is in inches.
Yeah, right. So then, since the cutter diameter is 0.4, then I changed the grid settings, set it into mm, into 0.4. So
Right.
after doing all those things, I started milling the board. There again, I found out that in the during, since the traces were not were uneven, so the milling also was not proper.
Right.
Okay, so I wasted the first board. In the second board, what we did is we used the vGroove router.
Okay.
In this image.
Yes.
So because of that vGroove router, the cutter depth was, though we kept it as 0.2, but maybe still due to some unevenness of the board bed level, it has totally removed all the traces.
Correct. So it's the function of the depth.
Yeah, function of the depth.
Yeah.
So I would recommend. I mean, it's recommended better to use a end mill cutter rather than
end mill cutter. Yeah, yeah.
So that is one thing. Then I switched it to end mill cutter. Then again there was a bed leveling issue.
Correct.
So this is also not feasible. So I think before any milling activity, two things we have to ensure is one is the end mill router, and the second thing is we'll have to level the board,
Yes.
the spirit level or a dial gauge indicator or something. Because
Correct.
when we go on to making bigger boards, we cannot take an heat of wasting a board.
Yes.
So again, finally, after doing all those things, today I milled this board.
Okay.
So at the end of the day, I was able to do this. I've completed the solder just now.
Okay, great. So
The component.
okay.
I'll be updating the website here.
Yes.
I've not shared the files also. So
Correct.
the programming maybe tomorrow and complete the activity.
Yeah, before the class, you should update your page.
Yes, yes.
And so what you can do is when you're adding all these screenshot, maybe you can make a video of it or simple GIF of it. You can club this image into one image, and it will show according to the time. So you will be wasting your. So you'll not be wasting the web page.
Okay, fine. I'll try to see how I can club these images into one thing, or how I can do it.
Yeah. So there's one utility known as Image Magics.
Okay.
In so which system you use? Linux?
No, this one, operating Windows.
Image Magic is the one that you can use.
Image Magics.
Yes, Image Magic. So this is a command line tool which you can install.
Okay.
And then through the command line you can make GIF of it out of it. You can use any algorithm to compress it. You can reduce the resample it. You can tweak the image. So this is a very good utility.
Okay, that means we can make a GIF by including all the images.
Yes.
Okay, fine.
So this is the tool, very useful tool. Even you can compress all of your images in the repository.
Okay. That's a good input for me.
Okay, great. Any questions, comments about this week?
The main thing would be, since I'm from a mechanical background, so I'm still trying to figure out why do we need all these things, components for just switching on a LED.
Okay.
Even with a battery, we can do the same. Okay. But I will go through it.
So you can add more intelligence.
Since we have, the LED has to be put on and put off using a program. So that's the reason that we are using all these things, all the components.
Yeah.
I'll figure out with the team how do we do it.
Right. So microcontroller is adding more intelligence to the circuit.
Yes.
Yeah.
So that's it.
Okay, great, nice work, very nice and well documented thing. Like every error that you have documented, which is really great.
Yes. Thank you.
Okay. Thank you. Hello.
Hi Yadu, this is Sudarshan.
Oh, I'm not Yadu, I'm Yogi. Yogesh. No problem, whatever. Sudarshan, who are you?
I'm a mechanical engineer.
How are you?
I'm good.
Yeah. So this is the week 6. How are you feeling about week 6?
It is good. It is really nice exploring this Eagle software because previously, before this exercise, during our small project, I have tried Fritzig and even Eagle. I found that Eagle is not so user friendly. With this exercise, we had a group discussion and some hands-on experience, and with that, I'm finding that this Eagle is a pretty nice software, and I can say it is really good. It is really nice and user friendly. So we have started with a group discussion and some sort of informal training, and we had a hands-on experience where Fab library under Eagle, and we found how to get those components on our schematic. So first we got that 80-44 in our schematic. Then using that net connector wires inside schematic, labeled it, means we have named it, and then put those labels.
Right, correct.
And whenever we found that whenever that label matches with the label on another component, it virtually connects it. So with that functionality, I found that I can create small modular things, and then
and interconnect them. Okay.
So that is what basic and the most important learnings I have got from Eagle. So it keeps our sketch neat and tidy. Okay, then if you then we went to board layout. We found that after creating a complete sketch, there are components which are randomly placed everywhere. So we have to align it and rotate and position it so that position it so that routing should be possible.
Right. Okay.
So first we tried with auto routing, and in auto routing, system itself takes care of connecting all of the traces, and sometimes it fails to connect. So in that case, we need to reposition the components, and whenever it succeeds, we can go with that thing.
Okay. So why this LED is not connected?
Because this is not the final sketch. I have drawn that intermediate sketch.
Okay. Okay.
Intermediate labels and how auto routing is done. And in this sketch, you can see that LED is connected. And in final sketch, you can see the entire thing is connected. And even it is tweaked to take care of minimum distance required for our milling cutter to cut. Our milling cutter is of 0.4 mm approximately. And I have tried, first I have used Fab modules to see whether entire thing is getting cut properly. When I have created the first sketch using auto routing and put it into Fab modules, I found that there are some places where it is not cutting. Means it is leaving those traces where it should not be. It should not leave those traces. So I have tweaked the board layout manually, and then finally, when I've satisfied and Fab module shown that it is cutting, then we have milled that board.
Okay, so one more screenshot that you have to add is of DRC while checking the DRC. Design rules. How do you check design rules?
I have checked it using, I have exported that PNG file, and then I checked it using Inkscape.
Okay, so before that, even you can check the design in Eagle itself. There's a DRC command with which you can check the design rules. And then you can specify what is the mill size and what is the minimum clearance that you can put. Okay, so according to our bit, we should put around 16 mil between two traces and between a trace and pad, so that you can check automatically using the Eagle software itself.
Okay.
So if you go to Chaitali's document, you will see how to check DRC.
Okay, fine. I'll check that.
Okay, so and where are your original files, original design files for Eagle?
Design files are there, and yet to add those.
Okay, and add a little bit of description also, because I can see only screenshots.
Actually, because this week is quite busy for me, and That's why I have not added any text, but I will soon I'll be adding it.
Okay, great. No problem. Okay, okay. Okay, yeah.
Okay.
Fine. Okay, so you have every screenshot of every step. Now you just have to add a text. What are you doing in that step?
Yes,
And
I
what
will.
is significant about adding that screenshot? Okay.
Okay.
Everything else is great. Okay, okay. Thank you, Sudarshan. Yes.
Thank you.
Okay.
Anyone else?
Yeah, who's next?
Hey, hi, Edu. That's it for us today.
Acha. Okay, Abhinay is not there.
No, he is not present today. Amol is also not there.
Okay, so is their documentation is complete?
They're still putting up. They haven't uploaded their website yet.
Okay, very special instruction for Abhinay that
Yeah.
he has to present his work tomorrow.
I have
So-
already about all this, and he should be there tomorrow.
Okay, okay. So he has to complete his final project as well as this week assignment and the last week assignments also. So maybe he'll be able to present in front of Neil.
Correct.
Okay, great. Okay, fine. So we will start with the Riddle Lab. So is Vigyan Ashram up? Are they online?
Yeah. Hi, Yogesh.
Yeah, yeah. So let's go to your page. Yeah, Mahavir, we can continue.
Right. So both the processes are going parallel to each other, as in the Photoshop file as well as the Eagle one. And I checked for ERC and ERC and everything.
Okay.
These were set at 0.4, but I still had to change it, and because it's changing the way the design is going. And the bit which we used one single routing for. I mean, so I used a 1.010 bit for routing the first first what do you call it? First turn or something, and then I used the 1/64 to mill the rest of the stuff. A separate file was made for that Shine one part. That's pretty much about the routing part.
Wow,
There
very
are three boards
nice.
even in this case,
Yeah.
the only new thing I think from my side, I mean, in terms of innovation, was that the to the person's head, it basically I gave it a stroke in Photoshop to make a black stroke to that white line. So the circuit inside the head actually has a black line on either side. So it doesn't in any way intersect with the head of that person. It's actually
Okay.
a previous week, so you have previous week's work as well.
Okay, okay. Any screenshots are missing or what here? Like four, I can see the placeholders only.
Right. I was editing those data. I mean, I haven't done anything, so I'll do all the documenting right now. This isn't the way it should be presented. So that'll be up by tomorrow.
Okay, great, great. So is your PCB working?
Yeah, the Fab ISP is working. This particular one I have
No,
to
this
program right.
PCB.
So this I
Okay.
have to program. I have to use my Fab ISP and program it right now.
Okay, cool. Yeah, very great work. Yeah, you both are making very nice PCBs, customized PCBs. Very nice.
Thanks.
Where are the original files?
So I'll upload that as well. The SVG file, right?
Yeah.
So
No, Eagle files.
The Eagle-
.sh and .board files.
So I'll put it up. I mean, it's not nothing is there. I mean, I just put the final image shot to say what I've achieved. How I've done it, it hasn't been documented. There's a Photoshop side of it.
Yeah.
So I'll put up simultaneously.
Okay, okay, great. So add documentation. So you have to write majority of the things before tomorrow's lecture and upload original files.
Right.
Okay, great, great. Okay.
All right, Yogesh.
Yeah. Thank you, Mahavir. Who's next? Hello? Hello, Vigyan Ashram?
So Vigyanashram from at Pabal, everyone is done. Jatin and Pratik are not
Pratik
available.
are not available. Okay. Okay, great. Fine. Okay, we'll start with riddle.
Perfect.
Okay, so Raj is going to present and he is with me. So I'll be sharing my screen. Yes. So yes, yeah. So hi Yogesh. For this week's assignment, wait just a second. Just see the URL. You haven't linked it. Yeah, I haven't linked it from the index page. Yeah. So electronic design. That was the assignment, and the first task was to select and use the software for circuit board design. And so I written a note like for this I selected 2 softwares instead of 1. So Neil just told us to experiment with the softwares. Yes. Try as many as you can. But for this limited time, I have tried only 2. And those are Autodesk Eagle and second is Cocopelli. Okay. So for the Autodesk Eagle, I have used my own machine, that is Mac OS, and on that I installed the Autodesk Eagle. Very easy to install, simple installation steps. And after installing, you have to import the library first, like and first you have to create project into the Eagle, and then you have to create the schematic. After you create the schematic, it shows a blank page, and in the blank page you have to add your components. And for components, we have to download one fab.lbr. I'll share the link for the same, where you can download it. And after downloading that, you can just import it into this Eagle software. Import the library. Yeah. So I have written the step like how to after downloading what to do. Like you have to copy into the LBR folder, and then it will appear in the library. This thing. So it is easy to manage your library if you keep all the libraries in the one place. Right. Yeah. You can also import it from the desktop, but it's not a good practice. Yeah. So again, then you have to click on the library and then use, and select a particular library. So it will be imported in your particular project. Okay. Then you can add the component using the add button, simple add button, or there is a text box. This is the text box. Here you can type add and then enter. It will also show the same screen. Okay. And this is a very nice tool, I say, and it also easy to create this kind of structure. For to get the knowledge of this design, I don't know what to do, what components to add. So I refer this tutorial. I have added a link of it. Okay. So when I Google searched about Echo Hello World, so it gave me this link, and referring the link and the design which was there on the link, I created the exact same design. Okay. Okay. And this is just like I replaced the resonator with the crystal oscillator. Okay. Because you also using labels. Labels. Yeah. Okay. Yeah. And after exporting into the PNG format, this is what I get. Like, after hours of unpuzzling this design and all. So I find it very difficult to get it straight lines, the lines that are not intersecting and all. So this was the final thing that I got. And using Cocopelli, it is thank God I have a Ubuntu machine at my home, and then which is like only dual core PC and 1 GB RAM, but still this software will run smoothly. Yes. And I have not written the installation step for this because this link is very good to install the software and all. So for Cocopelli, please refer this link. I'll tell to everyone like this is the best link to install the Cocopelli. But during the installation, there was a problem I got. Like some packages were not installed properly. So what I did, I ran this command sudo apt get update, to make sure like all the commands that I'm executing will go properly. So after doing this sudo apt get update, and then I redid all the command which is on this website, then it was installed properly. Okay. So after the proper installation, this is the first screen that you get. To make sure that this is the first screen, and if this is the right the screen that you get, the installation is proper. Yeah, that was also mentioned on that blog. Okay, so initially I loaded this hello FTDI CAD file given by the Neil himself, and I opened it in the Cocopelli. This is how it looks initially, and it is it is very good software, and everything is written, everything Neil has described in the simple language. And so I've written like some tutorials on how it works, so how Cocopelli works. So the file describes about the rules of designing and define the equipments. So the first section describes the output, like how your output will be, like this section. And then second section will define the shapes and transformation parameter, likewise text and class definition, PCB library, connectors, switches, crystal oscillators, resonators, diodes, and ICs. Okay, and after all that, I have gone through each and every every line, and after finally got the define board section. Just go to line number 3595. So after going to that line, I found the definition, like how to define your own PCB. So then Neil has written, a pre-written like how he has defined the PCB, and then after that, my task was to replace the resonator with the crystal oscillator, because this was available in my lab, and add LED and resistor and add a button. This was our assignment task. So these are the changes in the file done by me. That first I replaced the resonator, and then I have added everything, wire and everything. So after that, this is how the output looks like, and this is after milling how it looks like. So still it is incomplete, like there were a few components not available. So I'll just add this as soon as I get the component. That's it. Okay. Is the PCB working? So that I have not checked, because I had to add some component in. So I mentioned in my board, after milling and soldering the component, I have not added some component due to unavailability, hence the testing remains. So okay, so
what you can do is you can put the power using this connector. Yeah. This has got a VCC and VCC as well as ground pins.
Okay.
So you can directly connect these pins to your last time's fab ISP.
Okay.
And then you can test the PCB at least.
Okay.
And then you can try reading this fuse bits and signature of the IC. Even you can program it.
Okay, without adding this.
Without adding that. Because that is just a connector for interface for the other circuits to connect.
Okay, so I can do that.
So before the lectures, you should add.
Yeah, alright.
Okay. Alright, very nice documentation. So yeah, you haven't mailed the Eagle board? The board that you have mailed in?
I have milled it, but it was not milled properly.
Okay.
Yeah, so I will not share the screen. I'll add the image.
Yeah, add the image.
I'll add
the error
image.
also.
Yeah. Okay.
That is
fine.
That is important.
Yeah.
Okay. Good. Thank you.
I'm yet to complete the assignment, but what I've done is I've just started documenting it. Now you can go to the assignment 6. You can refresh it. Electronic design. You can click here.
Okay.
So basically, I've just started documenting it. So basically, used Eagle, and I've written here the setup steps. So SparkFun's tutorial is already there for setting up all the files in Eagle. So the existing board, what we have done is we have added a crystal, which is a 20 megahertz crystal, and it has 2 capacitors. So it's a time circuit.
Right.
And apart from that, we have added one pull-up resistor here and an LED, so that whenever there is a VCC, the LED will be on. And then there is one LED connected to pin number 6, so that it is controlled by the controller. So whenever we want to do a blink operation or test any application, so we can know whether the LED is glowing or not.
Okay.
So this was a composition of the circuit, and the board looks like this. When you there is a auto route function, so automatically it routes once you make the basic board frame, and this is how it looks like. But I'm yet to document it. I'm not documented it as of now.
Okay, so you have to add circuit diagram as well.
Yeah.
Because there is no schematic diagram.
Yeah, that I will be adding now.
Yes.
So I'll be adding all the details also, like what is the circuit doing, details of the circuit.
Yes. Okay.
And this setup also I'll be explaining.
You have to explain every step onwards. Yeah, before the lecture. Okay, great. Okay, thank you. So Amit will 117. It's taking too much time.
The file is actually. Just scroll it down. The electronics is there.
Okay. You can navigate through your page.
Yeah. Electronic design. So yes, I started like documenting and making a proper survey. So I'm a, since I'm an electronic engineer, so it was very easy for me to do the schematic and make the PCB as per my requirements. So because I know the background of the electronics, like what the things to be changed to do replicate the same process. So I will use Eagle for this. So in which I replace this like the hello world, basically the hello world PCB circuit to the new circuit that I wanted. So in which there is a resonator, I replace with the crystal 20 megahertz with the 210 picofarad capacitor, which will has an oscillating circuit. And then I had two LEDs with the color current emitting resistor over here. So one is with the VCC and ground to check the power, like it is a power LED. So to check whether the power is going to the circuit or not. So it gives us an indication whether the board is working or not, basically.
Right.
And the second LED is over here. So it is a programmer LED, like the Arduino pin like 13, which we have if you want to burn a code and check whether the code is working or not, the LED is working.
Right.
So we can program this thing right in the later. After 2 weeks, that has the needs that after 2 weeks we had to program this kit, like how to program and how to do these do different actions or tasks with this. So this LED will be like over here. I will code after like the shows me how to program it, and I added a push button over. The push button is at pin number 11. The push button is pin number 11 over here. So this is a push button which is like as in the documentation that we have to add at least a LED and one push button so that and make our own design circuit. So I added two LEDs for the one is power and one is the programmable, and there's a switch which will like turn off do the reset and kind of thing according to the program. So like the rest, the documentation is like very not yet proper. I have to document everything. So I just added a few, like this is a CAD, this is a traces file for the modeler, and these are the few images of milling after the process of milling with the modeler. Okay. And this is the final like output after soldering all the components.
You have to change this photo with this little blur.
Oh, okay, fine. I will change. I will keep this like HDR image over there. So this is the after soldering image.
Yes. One more thing that you have to add is the circuit diagram, schematic diagram, original files,
yeah,
and description about each step, each screenshot that you are sharing. Okay, great. Yeah, thank you. Yes. So all done.
I'm there.
Yeah, I'm there.
Okay. Who's that?
Lavina.
Lavina. Oh, where were you?
I was online from the session, 6:30, sir.
Okay, nice. So, how was the electronic design week?
Good. Again, not my background, so coming from a diverse background, learning about all these things is extremely difficult for me. Though challenging, I try and finish each and every task which is assigned in the tutorial so that I can follow up the steps and learn more things. So I started with Eagle. Can you pull up the website, or I'll do a screen share?
It'll be good if you can share the screen so that you can explain with your flow, your pace.
Okay. Share. Okay. So I downloaded Eagle just like all the other Autodesk features. I could easily download it. Then I learned about what kind of you need to create a new project uh, into the software. So you go to the project tree and create a new folder, which is your project.
Okay.
So what I figured out, these links, after I finished and I was trying to go back to my board or my schematic, I couldn't really go. So there was something called as EPF link, which took me to another folder where all possible files that I had created for the same project got saved. So it had my schematic, it had my board, it had my PNG file. So it was really helpful for me to find that. Then I downloaded the Fab library, and since I'm using Windows, I went to my C drive into the Eagle folder. I incorporated the library. Then learned about that Eagle works with two things. You have to create a schematic, and from the schematic, you start a board drawing. So the schematic, which pulled up another window. I added all the components using the add tool. And over here, you also had to check whether the library that you had installed in your drive has been updated. So I updated my library. I went to the Fab library, picked up all the components that I required for the Hello Echo board. Again, I finished my schematic all throughout, where I learned about how to route them, to label them. Each label, if when I named, they link to the similar, say LED links to LED wherever I put on the schematic. So those were my learnings. I initially started with something which was white in background in the GUI. So I really could not understand which is the component that is active. So then in the view mode, I changed it to black. So I could see that the components that I'm working on are active presently or not.
Okay. Okay.
Post the schematic was done, I moved to making a board drawing for the same. So there was a button to do the same, to switch to board. Into board, I learned that there are these yellow lines which you have to connect either manually, either by auto routing. And once you finish doing that, all these rat's nest or whatever, the yellow lines convert to normal red lines, and then your task is done.
Rat's nest?
So
Stupid, just stupid. What you did?
So all these yellow lines had to be connected to each other. So you route them, and a RatsNet would help you find the smallest possible location, or it will give you where you are linking it.
Okay. 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 So it will optimize the toolpaths. Optimize the
It will
route.
optimize the tool. So post doing a little of research on that, all the tutorials told that the all the components have to be incorporated in the board, which is the first check that you do. Then you do a convenient track creation. You do not place components too far or in a way where tracks complicate. You try to keep the board size smaller so that it takes less time to mill, and in space so that you can solder.
Okay.
First one I tried was by auto routing, and this is what I got, which was really difficult for me to even understand that what is linking up where.
Right.
And the track clearances were tracks were too close. So I realized that it will not really mill out well.
Okay.
So
how do you
I went about.
come to know about that?
There was a scale that a friend of mine showed me, where what the mill size will come out to be from here, the trace width.
Okay. No, but how do you understand that these are the two tracks which are too close? How can you?
with the help of this and calculating what the drill bit diameter is, he explained me that these are the tracks that you will manually lay on the board, and ISP may we had already milled one. So all the complications that arise that time gave me an insight that if I check the width of the trace, I will with the help of this scale I'll be able to visualize what my problems are going to be like.
Right. Okay. So there is one more command, DRC. Yeah, that you are using down
Huh.
there.
Right.
Okay.
So yeah, then came something new, which was a DRC, where I was completely lost because I did not find the DRC or the design rules for the same. So then after downloading that, I realized that जो मैंने पहले check किया था, it was incorrect, and now I'll have to do it with the Fab design rules. So I incorporated that in the Eagle software and again did a check. So this was the auto routing one was not really that kind of results. It was giving me too many errors. So and I could not understand those errors myself. So I thought I will reroute it by doing manually. So I started all over again and chose a track width of 0.03. After doing my first trial out here, I realized that it was very difficult to link things. So then I changed the track width to 0.01, which gave me more room, and again did the Hello Echo board there. Post that, I learned about layers in Eagle. So the tutorial said that you could keep just the top one active and rest all of them off.
Right.
Which gave me a result to something like this. Tried some more with keeping the pad, the dimensions on, and everything remains on the board. Then I exported the image by keeping the resolution to 500 using a monochrome picture and generated a PNG for this.
Okay. Okay.
I could not take a picture at the Fab Lab because already वहाँ पे जो mill कर रहे थे ना, on that machine also there is SEPT written. So then I have to either edit those photos or they don't go with me being from Riddle putting an image from there. तो मेरे को पता नहीं, तो मैंने वो डाला नहीं है image, but I've taken one.
Yeah, but that is okay. That you can use. No problem with that.
Okay. Then I soldered the components, and into this one of my 6-pin attachment broke. So I have just manipulated or I have just soldered the same pin which was broken out here.
Okay.
Single
pin. Okay.
To programming, I am really new to the whole world of programming, so it's going to take me some time to learn that.
Okay, nice. So where are your original files? Have you uploaded it?
Okay, I have, but this time, you know what happened with the Git push-pull also? There was a constant problem which I'm getting from past 2 days is something called as swap. There, every time I do a Git commit, it shows me that your folder is swapped and it gives me a long message. And after probably constant trying, it also solves it on its own. Kuch nahi kiya, to bhi it resolves. But I am still unable to understand what those errors are like.
Okay, so you post the screenshot in the Telegram group, so one of us can help you. Because without screenshot, I can't just tell what's going wrong.
Yeah, actually what happens is even the Fab Lab SEPT is like 2 hours away from where I am located, and I have my final jury going on presently. So in my final semester, so probably I have to solder this in the village as a sitting in some shop out there, and that is how I finish my work.
Okay, great. Fine, no problem. Just try adding those files or send it to me or any of the Riddle students so that he can upload. Okay. So
And
at
then
least,
next week I will be done with my churi so I can come back to Mumbai.
yes. Okay. And one more thing in the PCB,
Right.
what
Yeah.
what is there inside between two tracks? Yes, there.
Okay. Okay. That is the dust of the board which has got filled up in the tracks, and I was unable to edge them out. So it doesn't really make any difference in the connectivity. So I've let them be.
Yeah,
This
but
white colored dust, right?
yes, you have to clean it using water before stuffing the board. Or
Okay.
one more thing that you can use the steel wool to clean it. So it will
Okay.
degrease the surface also. So but degreasing with
Right.
wool that you have to do it before, and after milling that you can use any soft brush or any toothbrush to remove that,
Okay.
and then you can
Fine.
wash the PCB.
To make one more.
Why are you not cutting the PCB with Modella? You can see
Oh,
the bump here.
yeah. That's because there is no 32. There is no 32-bit drill bit out there. There is only one which is with the instructor, and only the academy students there are allowed to use it.
Oh, is it?
So, so I typically go in the night to work out my assignment there, and that time the instructors aren't available to get the drill bit in. So everybody else does it in the daytime.
Okay, okay.
So this time I have just manually cut. Last time भी मैंने manually ही cut किया था.
Okay, fine. I will talk to them. Okay.
In any case, I guess by next week I will be back. So the milling problem will any which ways be resolved. So
Okay, fine. No problem. Do you have everything?
yeah.
Okay, good. Try adding those this original design files before the lecture.
Okay. Yeah, I will do that.
Okay. Okay.
Yeah.
Yeah. Thank you.
Thank you.
I think we're done with all the students. Ajit. Ajit there?
Yes, I'm here.
Yeah.
Okay, shall we stop?
Yeah, we should stop. So
Okay.
we're done.
Okay, okay. Good
So
night.
share this recorded.
Yeah, it's recorded.
It's a link to the recorded video.
Okay.
Okay. Yeah.
Okay, good night.
Okay. Yep. Right. Good night, everyone.
Good night.
Good night.
Good night.